In this video, we'll look at the useEffect hook, which allows you to run side effects in function components. We'll incorporate side effects that do not require a cleanup as well as those that do require a cleanup. We'll also learn to optimize running side effects. So let's get right to it. One of the core features of a class component are lifecycle methods which allow you to run side effects. A class component typically features three major lifecycle methods. The component.didMount method is run synchronously once when the component is mounted into the DOM and is the perfect place to fetch initial data from a data source such as an API. Thereafter, whenever the component updates, the component.didUpdate lifecycle function, which also runs synchronously, can be used to run side effects and bring updated data based on a query, for instance. In this case, we can implement optimizations to ensure that side effects only run if a specific state or prop value changes. When side effects that require cleanup are implemented, such as timers or subscription-based services, the component will unmount lifecycle function can be used to remove the subscription or purge the timer instance. Traditionally, if a function component needed to implement side effects, the only way was either to turn it into a class component or encapsulate it in a class component that implements side effects for fetching and providing data. With hooks, this has become as easy as the useEffect hook. The useEffect hook looks like this. It is a function that implements a callback where you can define your side effects. Quite simply, the useEffect hook will run after every single render of the function component when the DOM update is complete. This makes it really easy to understand. Let's look at an example. Begin by downloading and setting up the project first and kickstart your development server. Our app fetches popular quotes and displays it on the UI. We get a set of category buttons here and the selected category, and down here we get the quote and the name of the author. The app itself is a function component that features a category component which renders the list of buttons and the selected category text. When a category button is clicked, the onSelected function is invoked and we can use this to set the active category of quotes. The categories prop here requires an array of category names to render the buttons, and the selected prop requires the active category name to display on the UI. On the other hand, the quote component simply takes a quote and an author and renders it on the screen. For fetching the categories and the quotes, we have a quotes service which contains an array of quotes separated by categories, and we have two functions to offer data to the caller. The getQuote function accepts a category name and returns a randomly picked quote object as a promise. The getCategories function, on the other hand, returns a promise that resolves with an array of category names. So first up, we'll bring these two functions into our app. I'll also bring the useState hook in because we'll need to instantiate a couple of state properties here. Our first state property will be used to hold an array of category names to render buttons on the UI. I'll thus instantiate the categories variable with an empty array first. We'll then set the categories prop on the categories component to our newly created variable. To get the actual categories now, we need to run the getCategories function when our app component loads for the first time. In practice, we need to run an effect that results in a state property getting updated. This is where we'll need the services of the useEffect hook. So let's import it first from the React library. First up, let's fetch categories on the first render of this component. To do this, I'll invoke useEffect, passing in a callback function where we'll run getCategories. And once it resolves, we'll check to see if the received array has data, and if so, we'll simply use setCategories to set our newly received categories. This is our very first side effect, which will run every time this component renders. You can see our buttons are now rendered based on the actual data received from our data source. Now, when the user selects a category, we want to store that selection in a state property called selected, which I'll instantiate first. We can now wire up our onSelected prop function to set the selected state variable whenever the user presses the button. This brings us to a very interesting yet lethal situation. You see, The useEffect instance function here is currently set to run at every single render of this component. Renders happen when a state property is updated. This means that this callback function keeps running forever, and more so when one of these buttons are clicked. This quickly leads to our browser locking up, leading to a potential crash at the end. You can see my browser is not responsive here. So how do I ensure that this side effect only runs on the very first render of the component and never again? How do we make this work like component did mount? The answer is the second argument to the useEffect hook, which takes an array of dependencies. These dependencies are variables such as props or state upon which our side effect depends. So instead of thinking like lifecycle milestones, it is better to think of useEffect as a means to synchronize an effect with changes to a specific dependency. The useEffect natively will run on every single render and update to the component. To prevent that from happening, we'll thus pass an empty array. We're simply saying here that the useEffect hook should only invoke the callback function when the variables in the array change. Since the array is empty, its contents do not change, and thus this side effect never runs beyond the very first render. This makes it theoretically behave like component did mount, at least for our understanding. Now, my browser locked up for good, so I had to crash and restart to get on with this project. So make sure you implement the second argument here before you hit that save button in your code editor. Okay, I'll open React DevTools in my Chrome browser, which is a free Chrome extension that you can install from the Chrome store. Here, if we go into components and select the app component, it shows me various state properties that I have in the app. When I now click on a button, you can see this second state property update correctly and the app stays responsive as ever. And since we are doing this, we'll also set the selected state variable to the first category name from the array that we receive. Let's also wire up the selected prop here to the state property. Now, whenever the app renders for the first time, the selected variable is set correctly, and it's also displayed here. Notice how clicking the buttons changes our active category now. What we want to do next is fetch a quote from our quote service whenever the selected state property is set. Let's say that again. We want to fetch a quote when our selected property is set. Note that I did not mention any lifecycle milestones here. This is because when working with the useEffect hook, you have to think of side effects and the variables they depend on rather than lifecycle methods or milestones. So to achieve our effect, I'll first create another state property named quote along with its setter function, and we'll set this to an object because we'll get an object from our getQuote service function. Then, just like useState, I can create multiple instances of useEffect to separate concerns and side effects. Here, we'll ensure that our selected variable is set, and if so, we'll invoke getQuote passing in the selected category string, and when it resolves, we'll use setQuote to update our state. But before hitting the save button, make sure you set the second argument as an array with the selected property reference like so. Here we are telling React that this particular side effect should only be run when the selected state variable has been updated with a new value. You can loosely compare this to the component did update lifecycle method, where we compare previous and current state and prop values to optimize side effects. Here, this is as simple as passing in the state or prop variable in this array. You can also add multiple variables to this array if your side effect depends on it. Now, when the app loads, this useEffect, like all instances of useEffect, is invoked first, in which case the condition that we have set here in the expression is not fulfilled since selected is initially not set and hence getQuote doesn't run. Meanwhile, our first instance of useEffect updates the selected variable, which then causes this newly created useEffect to run, and this time we do get a random quote from our quote API. To display the quote, I'll remove this hardwired quote and we'll simply wire this up to quote.quote and quote.author, since this is how we get the quote from our service. Here again, I've used a condition to ensure this renders only when we do have something in the code state variable and not otherwise. Now, when our app loads, we do get a new quote on the UI. And whenever we click on one of these buttons and the selected property updates, we get a new random quote from the service. Notice if I click on the business button again, I do not get a new quote because the value of the selected variable remains the same and hence our second use effect doesn't run. It, however, does when this value changes. Now let's take this one step ahead. Let's get a random quote from our service every 5 seconds. To do this, I'll create yet another instance of useEffect because this is, in practice, a separate and unique feature which should not be bunched together with other side effects as you're typically led to do in class components and lifecycle functions. Once again, our final side effect depends on the selected state property. Since we want a new quote every 5 seconds, I'll create an instance of setInterval where we'll fetch our quote and we want to do this every 5000 milliseconds. This works fine, only that every time we update the selected property and this runs, a new instance of the setInterval would be created because we are not cleaning up yet. In the useEffect hook, cleaning up a side effect such as unsubscribing from a service or cleaning up a timer instance is as simple as returning a function. Here we can invoke clearInterval passing in the timer ID, and this will prevent memory leaks by removing unused instances of setInterval. Once again, loosely speaking, this behaves like component will unmount but with an added feature. Not only will the timer instance be removed when this component unmounts, it will also clean up effects from the previous render whenever this useEffect runs. So every time you update the code category, the previous timer is automatically purged and a new instance of setInterval is created. This is exactly what we need. And this completes our little app. You can see our quotes getting refreshed every 5 seconds. Let's recap what we have learned here because it can be quite daunting. As you saw in this example, hooks are very different from lifecycle methods. While the functionality that they provide seems similar, they are not exactly lifecycle methods, but rather an amalgamation of functionality that may resemble component did mount, component did update, and component will unmount lifecycle features. Having said that, when trying to wrap your head around the useEffect hook, it is best not to compare or correlate the useEffect hook with lifecycle methods in a class component. This is because unlike lifecycle methods which run at specific times during the life of a component, the useEffect hook runs every time a component renders or updates. This also means that the DOM has updated by the time useEffect runs. So it is better to think of the useEffect hook as a way to synchronize an effect with dependencies. For instance, this instance of the useEffect will run every single time a component renders. If this effect updates a state variable, as you can see in this code example, then this becomes a runaway side effect which never stops, causing your browser to hang up. You saw this in the project demo earlier in this video. However, this one, as implemented in our example, will run only once when the component mounts and renders for the first time. This is because we are passing an empty array as a dependency. We are telling React to run the side effect defined here when the contents of this empty array update. Since that will never happen, this specific instance will run only once, making it work somewhat like the component did mount lifecycle function. On the other hand, we also had this instance of useEffect with the selected state property defined in the array. Here, the effect will run on the first render, and thereafter we are telling React to run the side effect only when the value of selected changes. We are syncing the changes to the selected state property with the side effect and consequently with the contents of the quote state property. Nowhere are we talking about a lifecycle event in this context. But when compared, this behaves somewhat like the component did update lifecycle function in a class component. Do keep in mind that despite this optimization, all instances of useEffect will run in the first render. Finally, when you return a function in useEffect, it is run every time a component unmounts, allowing you to implement a cleanup. But unlike its counterpart, the component will unmount lifecycle method, React will always run the cleanup of the previous render as long as the given property in the array changes. This means that this setup will clean up both on re-renders as well as when the component unmounts and is removed. The important thing about the contents of this array is that you must include all props, state, or other variables here that are needed by the side effect. And these variables must belong to the component's own scope for this to work correctly. If you don't include all the values that are needed, React will simply use values from previous renders and it might lead to bugs and unpredictable issues. Another thing to note here is that useEffect, like all hook functions, should never be invoked inside a loop, function, or conditional because it is not predictable, and one of the requirements of hooks is that they should be predictable to work properly. Lastly, you can separate concerns and implement multiple instances of the useEffect hook, unlike class components where you have to implement multiple unrelated code inside lifecycle methods. And when multiple useEffect hooks are used, they run in the sequence they are declared. This makes it easy for you to visualize which side effect runs when and makes the whole thing predictable and consequently testable. Alright, let's now take a look at the use context hook.